So this will be the last section on this unit on triangle similarity shortcuts. So there are 3 of them, and we'll talk about why you only need 3, whereas with congruent triangles we had to have 5. We'll talk about why that is in just a couple of minutes. The simplest one, and honestly the one that comes up more often in proofs than any other thing, is angle-angle similarity postulate, which we'll abbreviate with AA and then the similarity symbol. Okay? It just says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. Okay? With triangles, if the corresponding angles are congruent, it takes care of the sides being proportional. That's not true for other things. For example, if you have 2 rectangles. If you have 2 rectangles, are they both similar to each other? Well, maybe, but you could have a long, thin rectangle and you could have one that was basically a square. They're not going to be similar to each other because the sides aren't going to be proportional. But with a triangle, the angles is enough. And you're like, well, what about angle S and angle W? Well, what about angle S and angle W in this example? What do we know about them? They're congruent by the third angle theorem, right? By the third angle theorem, those 2 are congruent also. So you only need 2, because once you have 2, the third one takes care of itself. And if all the angles in one triangle are the same as all the angles in another triangle, the 2 triangles are going to be similar to each other. Okay, the second one is kind of the reverse of this. It's the side-side-side similarity postulate, which says if you've got sides that are proportional, and it's got to be all 3, then the 2 triangles are going to be similar to each other. So here I've drawn 2 triangles, a 3, 4, 5 and a 6, 8, 10. The ratio of the sides is 2 to 1 when I match up smallest to smallest and largest to largest. And so these 2 triangles, ABC and triangle PQR, are similar by side-side-side similarity. So a lot like side-side-side for congruent triangles, right? You have to put the similar symbol on this one. With angle-angle, if you don't, I kind of hold my nose and go, okay, yeah, I know what you mean. But here, if you put side-side-side, you put SSS without this, it means congruent. And you've done the wrong thing entirely, okay? So be sure to put the similar symbol. The last one is also like one of our congruent triangles, and that is side-angle side similarity postulate. It says if you've got 2 sides of one triangle that are proportional, not congruent, but proportional to 2 sides of another triangle, and the included angles are congruent. It's got to be the angle in between the 2 sides, just like with congruent triangles. Then the triangles are similar to one another. So here, 6 to 9, 10 to 15, both reduced to 2/3, and the included angles are congruent, so these 2 triangles are similar by side-angle side similarity. Now, you don't need to write this down, but when we were doing congruent triangles, we had a whole bunch. We had side, side, side. We had side, angle, side. We had angle, side, angle. And we had angle, angle, side. We also had hypotenuse leg, which we don't have for this one. So we've got a side, side, side similarity, and we've got a side, angle, side similarity. Why don't we need to have 2 different ones here? Why don't we need angle, side, angle, and angle, angle, side? Yeah.
Because those would prove that it was congruent, and then they're not, well, they are similar, but it's not, it only shows that they're congruent, not that they're similar.
Okay. What is yeah.
Because the third angle one already covers it.
Yeah. These 2 are already covered by angle-angle similarity. The other problem is that both of these only have one side. How are you going to say the sides are proportional when you've only got one set of sides? Now, there probably is a textbook somewhere that does hypotenuse leg for similarity. I just have never seen one. So a lot of this is just like congruent triangles. All right, so let's take a look here. Explain why each pair of triangles are similar and write a similarity statement. So these two triangles overlap one another. And I've also got these two segments are marked parallel to one another. Notice I don't have any side lengths at all. So I know it's not going to be side, 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 and I know it's not going to be side, angle, side. I already know this is going to be angle, angle. I just need to give enough information to show that it's angle, angle. So we need to have some angles that we know are going to be congruent to each other. So I'll take a volunteer to tell me some angles that are going to be congruent. Yes, ma'am.
K and L.
So these two are congruent?
Oh, sorry. JKM and KLM.
Okay. Yeah. And the second one you can call L because it's the only one there. But yeah, this one you can't call K. How do we know that those are congruent?
They're corresponding.
Are corresponding angles always congruent?
No.
What has to be true?
Parallel.
Yeah, the lines have to be parallel. So you can write something like this. The exact words are not super important, but something like this. Since KM is parallel to LN, angle JKM is congruent, and I'll just say angle L by the corresponding angles postulate. Haven't used that in a while. Well, that's one pair of angles, but that's not enough. I need two. Oh, okay. I could do the corresponding angles over here, right?
Oh, or J and J.
I'm sorry?
Or J and J.
Or angle J and angle J. Isn't it the same angle J in both of them? You could do either one. So feeling super lazy, I'm just going to do and angle JMK is congruent to angle N. And since it's for the same reason, we'll just shoehorn that in there. Therefore, triangle JKM is similar to triangle JLN by angle-angle similarity.
When will our first quiz on this be?
Ba-da-ba-da, dee-dee, da-da-da. Ba-da-ba-da, dee-dee,
Well, not on this
dee-dee.
one.
On what we're learning today?
On like this.
Oh, we have a quiz Friday, tomorrow. It won't include what we learned today. It will be the stuff on the first two. Or like last night's homework. Right? You guys all said, I had no problem with last night's homework. Yes?
Yeah.
Okay, that's part of what will be on the quiz. Okay? All right, let's move on. Here's one that's a little bit more difficult. So, we're given that angle R is congruent to angle LST. And that's all that they gave us. And there are no parallel lines, there are no angle bisectors. They didn't give us any sides. We know it can't be side angle side or side 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 similarity. Somewhere we've got to find another pair of angles that we know are going to be congruent to one another. Shall I give you a hint? One of the triangles, we're not going to prove the two little triangles similar to each other. The two little triangles actually aren't similar to one another. We're going to prove one of the little triangles similar to the whole big triangle.
Angle S. It's congruent to
Which angle S? There's three angles at S.
the RST.
Is congruent to what?
Never mind.
Okay.
I don't know.
This is not easy. It's part of why I do this example. All right, so this whole big triangle, there's an angle at R, there's an angle at S that encompasses both of those, and there's an angle at T. In this triangle over here on the right, there's an angle at S, there's an angle at L, and there's an angle at T.
Oh, T is congruent to T.
Yeah, angle T is congruent to angle T. It's part of this little triangle on the right, and it's an angle of the whole big triangle.
Well then, how come we couldn't do that with R?
With R, well, we already know that angle R is congruent to this angle. We would be, so in the whole big triangle, then the only angle you would have would be angle R. Right? You need two different angles in the big triangle and two different angles in this little triangle. So by the reflexive property, angle T is congruent to angle T. So triangle RST is similar, so that's the whole big triangle. R in the whole big triangle matches up with which vertex in this small triangle? Nope.
Oh, S.
R in the whole big triangle matches up with
Oh.
S in this small triangle. And we know that T matches up with T, so it's got to be SLT by angle-angle similarity. If you're still having trouble seeing that, try and imagine for just a second if I took this little triangle right here and I flipped it over so that it looked like this. Here's S, here's L, here's T. Do you see how this obtuse angle here looks like it's about the same size as this obtuse angle here? Those are the ones that go together that we didn't talk about. Okay. Some of the questions ask you to verify that the triangles are similar. So if you're going to verify, you just need to basically go through and go, okay, is it side angle side? Is it side side side? Is it side side side? And give reasons why. So for this one, we don't have anything about any of the angles, and they don't overlap each other, so we don't have any, common angle like we did on the last one. So it's going to have to be side side side. So I need to compare in the first triangle those sides to the sides in the second triangle. So Let's start. What's the biggest side of the triangle on the left? 6. It's KR. Not K6, KR. Did half of one, half of the other. So KR, that's going to be 6 over something. So I want to match that up with the big side in the other triangle. So I'm going to match that with KA. That's a 2-to-3 ratio. Then, well, I've got a tie for these other ones that are short in the first one. I've got KY, and I've also got KR. And that's 4 over the two small sides over here are KR.
Wait, wouldn't that be YR?
I'm sorry, YR. Thank you. It's like that's one too many K things. So then here, this is be KR and RA. That's 4 to 6, which reduces to 2/3. So all of these are equal. I'm going to add an equal sign in between those two to show all of those are equal. So this is side, side, side similarity. All right. Here's another one like that. Verify that these triangles are similar and find the length of MS. This time they did give us some side lengths. Let me show you what people fall for on this. People will write 2 to 4 and 3 to 6. And they'll go, those are 1 to 2, so the sides are proportional. What's wrong with that? Well, is 4 a side of a triangle? No. What I suggest people do on this one is take the two triangles apart. So this is triangle JAE, where we know this side is 2, this side is 3, and this side is 4. And then the bigger triangle, JMS, where JM is 6 and JS is 9. Just adding those sides to those pieces together. So I need to find MS, but I'm going to do that later. Notice it says and find, so you do that second. So let's see. If I'm matching up the other pieces, JA, what does JA match up with in the other triangle? JM. That's 2 to 6, which is a 1 to 3 ratio. And then JE matches up with JS. That's a 3 to 9 ratio, which is also 1 to 3. So I'm going to stick an equal sign between those two to say those sides are proportional. But that's only 2 sets of proportional sides. So I've got to do something with an angle.
Angle J is congruent to angle J.
Yeah, isn't it the same angle J in both of these? So angle J is congruent to angle J by the reflexive property. So this is side, angle, side similarity. Okay, any questions about that? Okay.
Wait, don't we have to find MS?
Oh yeah, we should find MS. It did ask us to do that. Well, we know the ratio of the sides is 1 to 3, right? So 1 is to 3 as what is to what?
4 to MS.
Yeah, 4 is to ms. So a pretty simple cross multiplication gives us that ms is equal to 12.
But why do you? I don't understand how you got that last part.
This part?
Like, yeah, that whole thing. I do not understand that.
Okay, so I took this ratio that I had for the other two sides, and I said the ratio of these two sides needs to be the same thing. Right? All the corresponding sides have to be in the same ratio. That's what it means when we say that the sides are proportional. So if the ratio of this side to this side is 1 to 3, then the ratio of this side to ms must also be 1 to 3.
Okay.
So I did 1 to 3, and then I was doing small triangle to big triangle every time. That's what I typically do, or I always go left to right. Doesn't really matter as long as you're consistent. So that's equal to 4 to ms. That's the proportion. Okay, and then we just cross multiply and solve it. Better? Okay. All right, so let's look at this proof. So, we'll do a 2-column. Most of you do 2-column proofs. You can do a flowchart proof if you like. So if we're given that those two lines are parallel, what conclusion can we immediately make? Yeah, angle C is congruent to angle T, and yeah, angle N is congruent to angle L. And how do we know that? Yeah, it's the alternate interior angles theorem. What's that enough to let me do? Say the two triangles are similar. Triangle CND is similar to triangle, make sure you match up the corresponding parts, TLD, by angle-angle similarity. And then they've written this proportion. CD to TD. Are CD and TD corresponding sides? Yeah. And CN and TL? Yep. So that's just the definition of similar polygons. Or I usually don't write it that way. I'll show you what I usually write. I usually say it this way. If triangles are similar, the corresponding sides are proportional. Okay? All right then. So quiz tomorrow over the stuff on similarity will not include today's lesson.